All right, hello everyone. So continuing along here with our series on supervisor alignments, we are going to tackle the next one in the list here, which is align HM-TEM. Okay, so I've got the cross grading sample in here. I'm gonna open up our column valves. Okay, and very quickly before I start the alignment, I'm going to check my monochromator because it probably will have drifted over the weekend. Okay, not too bad, but yeah, so I think I've mentioned this in some previous videos, but you want to do, again, if you have a monochromator with an XFEG, you want to do TEM work with a negative focus. When we're doing STEM, we actually go positive because that actually gives us higher brightness that way. But for TEM, this is better because we get more current with a negative focus. So that will become, so you want to make sure you have this set properly depending on what you're aligning. When we actually get into doing some of the STEM stuff, we're going to actually change this to the positive side. But anyways, let's see here. And I'm going to go ahead and check my C2 aperture centering. It should still be okay because I didn't move anything over the weekend. But we're going to check it anyway here. Okay, looks good. All right, go back to TEM mode. Okay. Uh, let's see, beam shift. Okay, so let's can check eccentric height here. So I can push eccentric focus. I'll go ahead and do that. Okay, and then we can focus with Z here to get minimum contrast. Yeah, so right about there. There was in some of the older videos, yeah, I apologize, there was a little bit of a ghost image in the blue cam picture. So I did take a new gain reference to get rid of that. So at some point I'll do a quick hitter video about how to do that with your flue cam, but it's really easy to do. You need a vacuum area, and then basically it's just acquire gain, and you follow the instructions. You spread the beam out as much as it tells you, and then it takes new gain references. The bias is done with no beam on the flue cam at all, so that's real easy to do. Okay, but anyways, we're not going to do that right now. So we're going to go to alignments and HM-TEM and basic SA. Okay, so it's telling us remove objective and SA. Okay, so those are both out, obviously. Now it's also telling us to select and center the 100 micron C2 aperture. We could do that if we wanted to. It's perfectly fine to do this though with the 70 if we want. Again, that's what we normally use when we're doing TEM mode normally. So, but I guess just for the sake of argument here, let's go ahead and just follow the instructions. Okay, so it's asking us to center, and you'll notice the C3 lens is off. So we're only controlling C2 right now, and we can see that that is way off. Again, with the C3 lens off, you want to go actually counterclockwise, crossover. And again, part of the reason for that is because we have the probe corrector in the beam path, so that introduces, trajectory changes. All right, that is pretty close. Okay, looks reasonable. Looks okay. Okay, that's good. All right, so it's asking us to center the beam and to focus the image. We don't really need to, I mean, we're okay right now. We're gonna maybe tweak the focus a little bit anyway, but we're okay right now, so I'm not gonna mess with this. And we'll click plus. If this was grossly out of focus, then yeah, you can go ahead and adjust the focus. All right, so it's asking us to stigmate the beam to make sure the beam is circular. And we're reasonable. Okay. Oops. It's asking us to use the ball to center it here. So I'm using actually the what's it called? The screen markings there to center it. Okay. I prefer to do this with the beam spread out, right? Because you're not imaging with the beam at crossover, right? When you do TEM, you're imaging with the beam spread out. So my opinion is it's better to do this actually with the beam spread out and not actually closer to crossover. This will be a little bit dependent though on the size of the beam. So, but this really, this doesn't impact your high res image terribly, unless it's like grossly crazy off. So that becomes more of an issue with the objective stigmator, but anyways, kind of neither here nor there, right? We're stigmated. Okay, minimize image movement. So this is doing rotation center now. Okay. So now here's where you are establishing like the basic setting for this rotation center. So when you load the alignment file, right, this is what you're getting. So it was a little bit off before, so we improved it here. Okay, so now it's asking us to focus the image. So I'm actually not going to mess with this. This is, fine where it is. This has already been set, but if this was grossly out of focus, then here's what you would do. And again, this is the coarse value, so that we're gonna do a fine adjustment in a minute here. Okay. Then it's asking us to focus the beam, focus and center the beam. I think we're gonna have to spread it out again anyway, so I'm not gonna go perfectly to crossover anyhow here. Yeah, now it's gonna mag all the way up into the highest SA mag. Okay, and now here's where it's going to ask you to adjust your image focus. And this is what sets the fine focus value for SA mode. Okay, so we can see that we're a little bit off here. So one thing we can do, we didn't set mechanical eccentric before. We can do it here. It's going to be a little tricky with the mag this high, but let's go ahead and do it. So we can turn this on. Yeah, so that's just, it's too high of a mag here to do this. All right, so what I'm going to do here, let me turn the wobbler off. Okay, I'm going to go back one step here. All right, and let's check it again here. Okay, so this is reasonable. Again, there's going to be some mechanical hysteresis when you set this. So I mean, if you're within, so the scale bar there says 500 nanometers. So you can see, like, if we're following this point here, we're deviating as we're swinging here, less than half a micron, which is fine. Okay, it's never going to be perfect. We can bump this up to 15. That might make it just a little more obvious. Yeah, so I mean, that's fine. We really can't get it any more precise than this. So we'll leave it alone. Okay, so we're at mechanical eccentric. Okay, so I'm going to adjust my beam here. Okay, we got a little, so we're closer to crossover. We got a little bit of condenser stig, but not a real issue here. Okay, so we can probably get this a little better here. So this is 62.25. I'm going to take a screen snip here. So we have this. Okay, and let's go ahead here. $62. Whoops. Okay, so basically we're only changing it. Yeah, so that's much better there. We can turn on the FFT to help us as well. Get that blow up condition. Yeah, so we only changed it 0.0268%. I do like to keep these with actually like round numbers. So if we actually put that at 0.2 or 82.277, you can see what it looks like at, yeah, so that's too much if we go to 82.28, although that's a nice symmetric number. So let's back this off. Okay. Yeah, we'll go to 82.2770. Okay. And again, there's going to be some hysteresis, right? That's why it does normalizations, or why it does a normalization when it's, setting eccentric focus. Okay. So, all right. So we tweaked that just a little, which is fine. And we didn't see any real astigmatism here in the FFT, okay? But if that was there, we can push R2 to toggle to objective stigmator to fix that. Okay, so we're good there. All right, so it's asking us to center the beam. Okay, if necessary, adjust beam diameter with intensity. Okay, so we're doing another rotation centering here because we just changed our objective setting slightly. And now you can actually see here, if I spread this out more, you can see the rotation around the edges of the image, right, as it's going in and out of focus. So that's again why they call it rotation center. So we're trying to bring the center of rotation to the middle of the picture. And that looks pretty good right there. Again, you can adjust the modulation with a focus step. Okay, we're looking good. Okay, so now we're in diffraction mode. It's asking us to put in an objective aperture and to check that it's in focus. Okay. And it's reasonable here. Do we check anything? Yeah, there's a slight deviation, but okay. Okay, right about there. Okay. All right, let's take out the objective. We will do the corrector adjustment alignment too at some point. Well, I've done that previously, but I will do it again as well. Okay, do you see there's a little bit of astigmatism there? So if we want to correct that, toggle the R2, and we can make the spot a circle, direct spot a circle. Okay, and then it's asking us to center the pattern. So we will. Okay, so now it's doing the beam shift pivot point. So this is establishing shift purity. So when the beam shifts, it doesn't tilt, it only shifts. So let's see here. This is actually helpful. If I look at the rings, I'm going to block off the direct beam here. and just look at the rings here. So we'll make the rings stationary. Okay, that looks good there. Okay, I'm gonna toggle to diffraction shift. Bring that to the middle, looks good. Okay, so now we're doing the image shift pivot point. Okay, that looks good. Okay, and that already looks pretty good. Okay, if it ain't broke, don't fix it. All right, and now we're gonna do the beam tilt pivot point. So this is, again, you have, you can adjust this directly normally. I'm gonna spread the beam out here a little bit more. There we go. Okay, looks good. Toggle to R2 to recenter. Okay. This is pivot point for diffraction shift. You're trying to minimize movement here. Yeah, so this is barely off at all. Okay. All right, and the last thing it's going to have us do is the rotation center one more time. We just adjusted all those pivot points. Okay, so we can see that's definitely off now, which again is understandable because we just tweaked all those pivot points. Okay, looks good. All right, I'm going to update my alignment file and we'll click next. Okay, focus intensity, center beam. So you can see it's got now our updated objective lens for SA mode. Right, so this is good. So we're seeing the sample in focus, which we should. Got a little condenser stig there, not really a problem. But what we're going to do here, so this is like what we did in LM mode, is we're going to make sure that we have that the image stays centered when we change mag. Okay, so that's what we're going to be doing here. Okay, so see, focus intensity, center beam. All right, let's just go to the next step here. Okay, so yeah, so now it's having us do the same thing. You decrease the magnification and just center the beam. Okay, so we're going to go down one mag click. It's going to run normalization. Okay, so it basically is it moving. So I probably don't need to do this. I'll go ahead and run through it anyway though, just so you know, you can see how it's done. But again, what we're doing here is we're correcting for shift of the image as the magnification is changed, okay? So if you're seeing that, then if you're seeing shifting of your image as you change mag, then this is most likely what is out of sorts. There's also a shift we have to do when we switch from SA to MH, which we will get to in a second here when we do the next part. Okay, so that was actually off by a reasonable amount there. Right, you notice that same feature is in the center here, okay? So that's how we know that this is working properly. Okay, so that's a little bit off. And again, this can be a little tricky when we're trying to align MH and SA mode. So again, you need a unique feature to keep track of with that. So with this cross grading, it can be a little tricky, right? Because everything looks the same. So we'll have to just I don't know if I still have the snapshot. I don't have the snapshot here still in TIA, but we'll have to find a clump of particles and find something in there that we can, pick out. Okay, so this needed to be tweaked a little, so good thing we're doing this. This is less time consuming in MH mode because in MH mode, there's only like 5 magnifications, I think. I don't know how many there is in SA mode. I want to say there's probably like, I don't know, 20, something like that. Again, SA mode really covers you pretty well. It goes, from the micro scale all the way to the, atomic scale. And the Technize and the Talos, they have that weird M mode, which, I never understood because it basically is just like an extension of SA mode, really. So it seemed kind of redundant to me, but that's how they designed it. But you notice on the Themis, they got rid of that. There is no M mode. It's only SA, which makes perfect sense to me. Okay. I think we got 2 more mag clicks to go here because this stops at 2550, I believe. I do eventually also want to do a video on performing the calibrations as well, which are they're by and large automated, but there are some aspects to doing that that can be a little bit tricky. So that would be, will be a good video to do at some point is how to run the automated, calibrations on your FEI S-TEM. Okay, and then that's the end of it, right? I can't go any lower. All right, so let's update the file. Okay, click next. And then we're gonna do MH mode. All right, so first thing it's gonna do here is is it's going to have us, we're already at eccentric height. So now we can make and the focus looks reasonable already. I mean, we can check the FFT here. I mean, it looks pretty good. So one thing we could do here, again, we have the, if you have the piezo enhancement, oh, I don't have it on. Ew. I don't want to do this. Well, yeah, I'll go ahead and do it. Okay. There's going to be a little bit of, why are you not enabled? Come on. Ow. That's not good. What's going on? All right, well, we'll have to deal with that later. Anyways, so we can try and do this with just the regular CompuStage here. Okay, so I'm just very finely tweaking the Z-axis. Okay, that's good enough. Now we need to keep a feature centered here. Okay, so I'm going to use this. Now again, I'm going to take a snapshot of this and send it to TIA so we know what we're looking for, right? Because again, this might get a little tricky to keep track of here. Okay, all right. So we're good there. And now it's putting us into MH mode. And now we have to set the focus again. So just like we set the focus for SA mode, we can set it in MH mode. Okay, so just like we had to increase this slightly when we went into when we changed this for SA mode, we're going to have to do this for MH as well. Okay, so oops, all right, I don't need to do that. Okay, so you can see there's a little bit, that's the condenser stigmator. It's not letting me adjust the objective, but it's asking us just to set the focus. I think I might be, yeah, so I can do it here. If you find the stigmator panel, you can pull it up here. Okay, so that looks better. Okay, so I'm gonna actually increase this to, it's a little too much. I wanted a nice round number. Okay, we'll go. Yeah, so you're gonna drive yourself crazy staring at this for too long. All right, we'll go right there as I waffle on this. All right, we'll go 82, 1970. Right, that'll be our new value here. I can still see if I change this to height. Well, that's not going to do anything for the FFT. Oops. Okay, you want to again slight blow up here. That ring. So yeah, it's right about there. Now we don't have an objective aperture in, so that's gonna change this a little. All right, there we go. 82, 1960. All right, there we go. Accurately focus image. So we're good there. Are we centered with the beam? Okay, so it's asking us to, with the multi-functions. So this was the clump of stuff. Yeah, this thing right here. So we're already pretty close. Okay, so we're doing the pivot points now in MH mode. Okay, so you can minimize the image movement here as well, because this is the image shift pivot point. You can see, yeah, so it's doing the same thing. Can you adjust the amplitude of this? Yeah, so I'm changing the focus ring, but it's not really doing anything. So I guess you really can't here. Okay. All right, we'll call that done. Okay, and then it's saying if it's necessary, you can toggle to image shift. So it's not off by much here. Put that in the middle. Okay. And now we're doing the other pivot point. Okay, looks good. All right, so it's not. Okay, very good. It's already centered. Okay, that's basic MH. Okay, so here's where we're going to adjust to make sure we don't get a shift when we're switching from MH or SA to MH, and when we don't get shifting as we change the mag in MH. Okay, all right, so we're already there at eccentric height, focus intensity, center beam, going counterclockwise from crossover here. Okay, so it looks like we might be like very slightly, and unfortunately, I don't know why my piezo is not coming back to me here. Okay, that's good enough right there. So again, when you're switching between them, right, you're changing your objective lens, so it's going to have hysteresis. That's why you run normalizations. Okay, all right, so we're good there. Okay, so now it's asking us to center the beam, right? And now we're going to increase the magnification and recenter that feature each time, okay? So we're going to go up. Okay, so we can see this is actually off a little here. This is the feature right here. There it is again. Okay, so we did need to do this, so that's good. All right, I think there's 2 more mag settings here. That's it right there. Start to see the lattice fringes really easily. And I think this is the highest it goes, is MH 1.1 million X. Okay, and there it is. So you can see how tricky this gets, right? So you're trying to keep track of what's what. This is the feature though, okay? You can see it right there, right? And you can see it right there, okay? Okay. So there's a little bit of a focal discrepancy again, right? Because, you know, it's not reproducing it, especially when you're at these crazy high mags, you're going to see the effect of that hysteresis really, really evidently, okay? Yeah, so I can't go any higher in mag, so, okay. All right, so let me go ahead and save my file again. All right, and we will move to the next one, which is all camera lengths. So we're gonna push the next button here. Okay, it's asking us to check that we're at eccentric height. So we already know that we are, we just did this. Okay, center beam. So we're center, I mean, again, we want to run this, we can run it. Yeah, so within the amount of slack we have there, we're perfectly fine. Okay. All right, focus diffraction pattern. Okay. All right, center pattern. So this is basically as we change camera lengths, we want to make sure the camera length or the pattern doesn't shift. So that's all we're doing here. So we're starting at the shortest camera length, which is 29.5 millimeters. So we're not going to be able to see a whole lot at pattern is going to be very, very magged out. Okay, increase camera length, one click to 37. Okay, I'm starting to see a little more detail. And this is really not off by much anyway, but we'll go ahead and do this. So this is where high resolution mode can be helpful. So it gives you just an extra bump in the mag here on your flu cam. So there are two more optional alignments here. So all SA mags fine, all MH mags fine. So what that's basically going to do is it's going to give you the option of setting the focus to be mag specific. So as you change mag, your objective lens is going to change with the mag. Again, that's an optional adjustment. I don't like to do that personally. I like to keep the objective lens set within one of those modes. So it's only one value in SA and one value in MH. I think it just simplifies things more that way, but that's, again, my personal preference. Okay, we're doing good here. We're up to 91. Starting to see some more detail here. So I think if I remember from when we did Align LM, what was the shortest camera length there? I think the longest camera length was like 900 meters. So I want to say it was something on the order of like a few meters, the shortest camera length in low angle diffraction mode. So we're probably going to have to go all the way up to around a meter in normal diffraction mode here. So this is diffraction mode that you get when you swap from SA or MH mode and you go into diffraction. This is D mode and as opposed to LAD mode. Oops, I went backwards. Okay, my bad. Okay. Okay, that's good. It's good. All right, so at this point, we can probably turn off high res mode. We'll go ahead and do that now. Yeah, so we don't need high res mode anymore. So that's off a little. So yes, in your alignment file, right? So this is where you're getting values for all these deflectors. Actually, you can see this here. If we pull up system status, you can actually watch, see, this is changing, right? As I adjust my multifunction knobs, the magnification correction, which is a fancy way of saying it's, this is what it's correcting to keep the pattern centered as we change camera length. That's why they call it magnification correction. Okay, so now we're getting into above a meter. Yeah, so now it locks you out of changing the condenser after that initial step. So like I'm turning the intensity knob, it's not doing anything, which is fine. You don't really need, this doesn't need to be perfectly focused to do this. You're just centering the spots here, but this looks like it's might be off slightly. .85 meters. So I may have mentioned this at some point, but the reason they call it camera length is because originally that's literally what it was. So when you were taking diffraction patterns, you would have a distance, physical distance from the sample to the pattern, right? Sorry, from the sample to where the pattern was collected on the camera. So, and obviously, right, as you moved farther away from the sample, the pattern would be magnified more. So that's where the term camera length came from, right? So there's actually no more, right, physical distance between the, in this case, the SATA camera or the flue screen and where the pattern is coming from. This is all done by lens manipulation, but we still use the term camera length anyway, okay? Just as, to pay homage to this. All right, and go ahead and save my NRF file again. Okay, and I'm not going to do these other ones, so I can't go any higher, so we'll click done. Okay, so my beam is just really spread out here. All right, beam. Okay, there we are. Okay, so that is the Align HM-TEM supervisor alignment. Okay, so we'll move on to the next one here in a minute.